All right. So I think most of you guys already know that we announced in partnership with Litmus and a few other partners two new solutions in Hannover Messe. One is called the Manufacturing Data Solution in Fabric, and the other is the Azure Copilot template for factory operations in Azure OpenAI. So a lot of words there. It's a big name, but yeah. So the kind of the premise of this was, as we were looking at our industry clouds and the formation of the Microsoft Cloud for Manufacturing, we looked at what are the problems manufacturers are really facing, and what was as we kind of talked to various organizations and our customers, a few things kind of merged right to the top. One was that there's just a lot of data silos that exist in manufacturing. Data is kind of spread throughout. There's a lot of challenge in actually doing AI projects on top of those. Not only Gen AI, but even traditional AI projects, because you have to kind of bring the data together. You have to kind of make sure it's in a good shape, and then you can do these things. And typically, they're not very connected, and so you don't get the full value of these projects. Um, Another thing we kind of heard was that a lot of times the frontline workers run into a lot of issues in the factory operations, and then they tend to basically have a lot of lag in the way these things are solved. They may have to engage data engineers, data scientists to figure out, hey, why did something go wrong? What was the root cause of my line having a problem, or why did my yield go down? And that process can take hours, can take weeks, can take months. And if you don't get resolution, you can have a lot of wastage happening and inefficiency happening in factories. So we heard all of that, among many other things. And one of the things we wanted to do was create a unified manufacturing estate in Microsoft. And recently, we've been, for a while actually, another group in Microsoft's been working on creating a unified data for Fabric, using Fabric. And the idea of Fabric is to really kind of bring all the data in one lake, so that you have the data on which you can easily create Gen AI projects. And when you have data in one place, and you are able to then do Gen AI project, it becomes an exponential curve, because you don't have to spend the same amount of time going from use case one to use case two, or from use case two to use case three, and so on. So we had a unified data lake with Fabric, and so we wanted to bring the manufacturing estate in a kind of an open standard ontology that would be sitting in Fabric and would be easily accessible for Gen AI projects. So that was kind of one of the first thing we did is with this solution is kind of bring that in using ISA 95 entity data model, bring all of the data into Fabric and create a unified estate. The second thing we did is, well, how do you then bring all of this data to accessible to frontline workers? And with all of the innovations that have been happening in Gen AI, one of the key breakthroughs that have happened is the ability to use natural language in a really robust way for frontline workers to ask any questions that they are interested in. So we wanted to take all of this factory operations data and actually empower frontline workers with natural language interface. And the fact that we have all of this data in a particular way, we're able to ground these copilots in a very coherent way and actually provide value through copilot templates. These are not finished applications; these are copilot templates, because we expect our partners to create finished solutions on top of that. Now, as part of this announcement, we've also announced a bunch of partnerships, especially, for example, with Litmus, which has a coverage of very large number of brownfield protocols and estates across various manufacturing companies. Litmus connects into MDS to bring all of that data in across various these brownfield estates into this unified estate that I was mentioning earlier. So that is kind of the high level of the announcements. We are very excited to have this out now. We've been working on this for a little bit of time, especially Abhinav. And we are excited. We are seeing some great momentum. Obviously, we're still also learning and hoping. This is a preview product, and as we kind of work through it, we expect that to be great value for our customers as they progress.
Yes, and very good intro. And I think one thing that I would also add from the technology point of view, as factories are being built, newer factories are being built, there is another problem of actually replicating the solution across these factories in a very, very rapid way. So other thing that we are doing from the MDS point of view is we are creating this as a resource within Azure, so you can basically templatize it from one factory to another. So the time to actually digitize your factory is much lower because now you have a fully vetted out solution end to end.
With that, any questions?
Thank you for the introduction. Like it's very helpful, and just to also know that like Litmus is playing little role in this big journey for customers. So that's exciting, and I know like team members from Litmus have been working with Microsoft Teams for some time, like just to prepare this for now. One of the questions that I had, like for this uh, technical piece specifically, currently the approach is that like we bring the data into the fabric and it's actually transforming this. So what sort of integrations you are actually envisioning out of this one? Let's say, are you thinking about more data streams, or like what sort of approach for this bringing more data to the actual data lake?
So I think, let me start by saying that Litmus is not playing a very small role. It's playing a very big role, crucial role. And in fact, I've met maybe over 70 customers at my booth in last, few sessions. And many of them are struggling with this problem that they have brownfield factories, either factories that they have recently acquired or they've already had them, but there was no way to digitize them. So the way Litmus, and every time I hear this, Litmus comes to my mind, and I've been, pitching Litmus left, right, and center for this. So a lot of data connectivity from into the end piece softwares, right? Litmus is handling. On the machine telemetry side, we are standardizing it using OPC UA PubSub, right? So Litmus is also helping in bringing all of that OPC UA PubSub data, bringing it into a unified space. Then we also have connectors from MES. We have connectors for different systems, including Dynamics, etc. So all of this data, when it comes into your raw data or Bronze Lake in Fabric, after that, there's another step to unify this data into a single data model. That's the ISA 95 data model. So it has a companion spec for OPC UA. So that's how all of the data starts coming together, and then we create a knowledge graph out of it. So at the end of the day, a factory operations is full of people, machinery, telemetry of that machinery, state of that machinery, people who are working on that, products, supply chain, everything. So all of those things, once you capture in the graph, the analytics on top of it becomes a whole lot more richer.
When you're chatting with customers, and what do you see as some of the big outcomes they're looking for as they unify their data in Microsoft Fabric? What are some of the biggest challenges they're looking to tackle?
You're giving me all the hard questions. Huh? Okay. Look, I think one of the challenges, as I mentioned earlier, there is a very fragmented data estate that a lot of manufacturers have. And so, ability to have a unified data state is obviously a very good aspirational thing. But the question is, how do you bring it together, right? That's not an easy process, especially if you have it in various other storages or formats or other clouds. Now, we have solved some of this for our customers because you don't need to physically move any data into Fabric. You can short link that. So you can have the data sitting in other clouds, and you can do that. Having said that, we've also adopted an open standard, which is Parquet, because we really believe that having an open standard is kind of the way to kind of bring a lot of the data together. But that's not true for all manufacturers today, right? Not all data is in Parquet. So those are some of the challenges we are likely going to run into in some of our onboarding. So those things, once done, have certainly some cost to them. But once you do that and you have it in Parquet format, and it's in Fabric, then it opens the data to not only the Copilot template that we are put on top of Fabric, but Fabric is now has a lot of various services, all of our data services actually running on the same format. So if you want to use, Custo, which is our time series data explorer, you can do that on top of Fabric. You want to run Spark jobs you can do that on top of Fabric. You want to do Power BI dashboards, you can do that on top of Fabric. So you get a lot of automatically services working if it's on Parquet. But that's kind of one challenge, I think. The other challenge is that, you know, I would say that, as we are building these Copilot templates, we have to make sure that we are able to answer these questions with very high precision. Because you can kind of think of Gen AI in two categories. One category is where you use a Copilot as a starting draft. Okay, that I think a lot of people are now familiar with. Like, you have a starting draft, and then you go and you kind of make it better as a human there. When you are doing a Copilot template for a frontline worker, precision is of paramount importance, because it's not a draft. They're actually asking for a very precise question and a very precise answer. So we want to make sure that we, because these are AI generated answers, that it's not in an automated flow until there is some scrutiny to these things. And so those are the challenges we're working through with right now with our customers, to make sure we can train the people who are using it, because this is a different flow, this is a different process. They get a lot of value out of it right away, but it's a little bit of a change in the way the process is working. So those are kind of some of the, I think, onboarding obstacles, kind of as we are thinking through some of these. Like all previous things, it takes a little time to kind of fully flush these things out, but that's kind of the process we are through.
Just to add to what you were saying, if I was to summarize it in one line, people think that AI is a silver bullet, it can be applied anywhere and solve every problem. And I think that's part of the education that everybody is going through right now, that LLM is really creative, right? If you think generative AI, it's very good at generating things that do not exist. So how do you actually make sure that it only talks about things that exist in reality? And I think that's where a lot of grounding techniques need to be applied, and a lot of that value is hidden in the data itself. So how do you work with the customer to ground their data, or use their data to ground LLM, give them the right responses? I think is one of the bigger technical challenges. But on the flip side, what we are also hearing from the customer that they would love to get solved, and we are solving it for a good extent, is right now they only have dashboards that they look at, and there are hundreds of dashboards sometimes, right? So there's an information sort of overload or blasting of these mini KPIs to them, and they just don't know how to sift through the information that they're looking for. When you have an LLM that works on top of a knowledge graph, you can now sift through that knowledge very, very quickly in a very precise way. So yesterday I was showing our dashboard to somebody, and they were like 20,000 data points, but I literally asked, like, hey, what is the reason for drop in yield? And LLM could just find out the answer very trivially. So in order to reach there, of course, there's a lot of hardening that needs to happen. But ultimately, that saves 2 hours of time, right? So I think that's the tremendous value that the customer is looking for.
So from a value perspective for a manufacturing customer, like all the interactions that you're having, are they more AI driven, or are they more that the customer really wants to organize their data better? Because without the data, there's no AI that's going to be effective. So is the AI more so glamorous as of now, and then the customer really wants to get their data prepped? So, I mean, just want to understand the dynamics there of the interactions that you're having with customers.
Yeah, definitely. A very good question, actually. Thanks for asking this question, because I think, look, there is a buzz for AI everywhere, hype, hype, hype. But looking beyond the hype, when I'm talking to actual customers, it's 50-50, right? Or maybe 60-40, 60 towards organizing their data to break down the silos, having one real estate of data that is solid. They know that the copy that they have of this data is actually true copy. It's not like it doesn't have holes in it. They can merge the data from various sources seamlessly into it, and then they can put a data engine on top that can extract all of the data out, regardless of which source system it's coming from. So definitely a tremendous value there. Because right now, if you look at big data world, that is separate. If you look at transactional databases world, it's very, very separate. So how do you merge all of that together is one of the bigger themes here. Then once you've done that, how do you make this reporting more dynamic is another challenge that they're asking, and that's where the AI is useful. Of course, there are point use cases as you're building, your pipelines through Fabric. You can use Copilot to actually manage your pipelines or build your pipelines, but that's more, I would say, procedural kind of thing. But really, in the generative AI point of view, people are mostly looking at a unified data estate and how can I actually reduce the time it takes today to extract the answers out of that unified data estate. And I think that's the right application.
So I asked about challenges, but now I want to talk about catalysts. Do you see some kind of catalyst, either external in the industry or within a particular competitive set of companies, that really move forward companies from lots of POCs and pilots to actually broader adoption? Do you see any catalysts that are happening now or that you anticipate that kind of lunges companies forward?
You took the hard question. That's good.
Take the hot plate when it gets back.
Yeah, that's how a team works.
So, I would say that most people are at this point recognizing that, technology trends don't come linearly. Okay. Actually, someone asked me this question maybe on a panel 5-6 years ago. Where do you think the technology would be 5-6 years from now? I mean, like as in current time.
Yeah.
And I said I have no idea. But one thing I do know is that most technology trends are not linear in the way they embark on. And whenever there is a technology trend that is, quite transformative, you see an exponential curve in the way the adoption happens. Now, we've seen that many times. We've seen that with the adoption of internet. We've seen that with the adoption of mobile. We've seen that in adoption of cloud. So there is no reason to expect that when there would be a transformative change in AI, you wouldn't see an exponential growth in adoption. And I think that's what we are seeing now. We have an inflection point happening with generative AI. It is not a linear change in the way we think about the usage of these LLMs or foundational models. And we are seeing an exponential curve. So I think most executives across the world now, I think, have kind of come to, I think, this point of view, or haven't, will likely come to this point of view soon, that is probably going to happen. And so I think almost every organization now is thinking, well, how do I use generative AI? How do I bring it to fruit into production scenarios? Not only to do cost saving and efficiency, but also how to innovate and disrupt the markets that they're in. Because, this is when you have a disrupting force, it is good to be, in the center of it and not wait it out. So I think though a lot of things are in early phases right now, I think we will see a strong momentum as the wave continues. And so, yeah, I think that, I don't know if I answered your question, but that is kind of my point of view in terms of the way the adoption.
Yeah, and I could add a couple of things as well. So I think as the inflection point comes, there's suddenly a new area that's opened up, and then you see new obstacles. So I think the catalysts are really going to be the obstacles that we're seeing right now. So for example, the whole industry's over dependency on GPUs. So how much can we scale out of it, right? So how do we transform ourselves from saying, okay, now we understand the power of this technology, but it cannot just only run on GPUs. Can it run on certain other devices? I think that's the next generation of disruptive AI trend that I expect to see. Other than that, there's also always this thing of, can I run these kind of things on edge, right? Right now, it is not possible, like to have such a large language model to run on the edge. But as we see the value of a linguistic model, right? I think the next generation would also be like, how can I make it so that it can run on a point use case on the edge, which I think would be another catalyst moving forward.
You mentioned about small language model. Would like to know a little bit more about that and how we can potentially use it with our edge ecosystems. As Abhinav just mentioned, that there are possibility to bring this model back to the edge, and what sort of use cases we can work together on this new path.
We can build a sci-fi movie. No, this is a hard one.
There's a pattern here, I think.
I
going
think
on,
so.
right? Okay. Okay. So look, as Abhinav was mentioning, large language models take a lot of cost, time, and expertise to train up. And they are very good and very accurate and great things to get started with. But there are scenarios where they may not work great on. For example, edge scenarios where you're disconnected from the cloud. You need LLMs to be on the cloud right now. You also have scenarios where you want it to be extremely efficient because you're doing super high set of volumes in a very short latency. Let's say billions of calls happening, let's say on your mobile phone. Again, it may not be the best technology for that scenario. So there are scenarios like that, edge, autonomous, objects or such things where you want high efficiency and cost structure, where scale is very, very important in a very, specific way. And you're okay to take maybe some lag in accuracy. Okay. So in those cases, we have now seen a new set of generation of models called small language models that have popped up. Microsoft actually announced its latest small language model yesterday. It's called Phi 3. And if you look at the benchmarks that came out of the paper yesterday, which was my midnight reading last night, is that these models are now not only, by the way, these models are only about 3 billion in parameter size, so like 3.3 billion parameter size compared to hundreds of billions of parameters that large language models have. But they're still trained on trillions of tokens. But they're still very small. They can be run on a phone. And these now, if you were to compare it to the benchmarks of other small language models, not only are they beating all other small language models that exist out there, but they're now also very competitive to some of the older versions of LLMs. So when you look at, let's say, some of the older generation of LLMs, they're actually competitive. You can take a look at the benchmarks that were published, and it's quite surprising. So things are moving very rapidly in various spaces. LLMs are getting better, and so are the SLMs. And depending on the scenario, you can certainly look at the family of these models and see what's appropriate to be used in what scenario. And I'm excited about these SLMs because especially in manufacturing, there is so much disconnected state. And one of the challenges, to the point earlier, is going to be how to bring Gen AI to these disconnected edge devices. And I think SLMs are making some very rapid progress, and so you can go check it out. Phi 3 is open source, so you are welcome to go and train it with very specialized data if you want to. Obviously, it works out of the box for a class of problems as well. Yeah, so it's coming quickly.
No, I think this is a complete answer.
I actually think that's probably the best answer I've heard around taking the scale and depth and precision of a large language model, and then actually talking about how an SLM can actually surpass over time as they get better and enable those edge scenarios. I think that's the clearest description I've heard in the past year that actually seems plausible as opposed to theoretical. So I really enjoyed that description. So thank you.
Yeah, I would clarify one thing. I'm not saying that it would necessarily surpass, but they're becoming competitive to the older generations of LLMs.
Yeah.
There's, I think, always going to be a bit of an accuracy gap between LLMs and SLMs by the fact that you have just these large models trained in ways that give it that level of advantage. But certainly in scenarios where efficiency and cost are important, that lag may be okay for certain scenarios.
Right.